There's been a lot of stuff happening this year that's just been too much. Okay, here we go. So, fractions. We are moving into adding and subtracting rational expressions. So far what we've done is simplifying rational expressions. We have multiplied them and divided them, and now we are doing the adding and subtracting. We save the best for last. Okay, so there is a rule when you're adding or subtracting fractions so that you are able to add or subtract them. What is that? Does anybody remember that rule? Jade? Good, the same denominators. Excellent. Everybody give it up for Jade. Okay, when they have the same denominators, like in this first one, we have 1/8. Who is talking? Shh. Well, like 1/8 plus 5/8. How do I add that? That's 6/16, right? It's funny, I used to say things like that at my old school, and they thought I was serious. And they're like, you're the teacher, right? Like, shouldn't you know how to do this stuff? I say that to get your attention so that you're... Okay, anyway. So, what is it? So when we add 1/8 plus 5/8, we get what? 6/8. The denominator stays the same. And then what? We reduce. What can 6 and 8 both be reduced by? 2. Good. So if we divide both by 2, we get 3/4. I also had a kid ask me, are you guys ready for this? This is stuck with me for the last 6 years. Miss Miller, what's your last name? Just like, oh my God, where am I? He was serious. And fortunately for me, there were other people in the class that were like, dude, seriously, are you asking that question? So I didn't have to say it out loud, but yeah. And then he was like, oh yeah, okay, I get it. Now, in this next one, 1/3 plus 2/5, we obviously do not have like denominators here. How do we get them to be a like? Kendra. Good, the least common denominator. Everybody give it up for Kendra. So what is the least common denominator for 3 and 5? 15. Good, 15. So, hey, who is talking still? Yeah, she's quiet, actually. People over there, stop talking. Okay. So, the least common denominator we said was 15. What do we have to multiply 3 by to get 15? 5 over 5. How about this one? 3. Okay, so we end up getting 5/15 plus 6/15, which comes out to how many 30ths? Just kidding. How many?
11.
Can we reduce?
No.
No. All right. So that's, I just want, we're doing this. I know this is very, very not difficult for all of you. But so keep this process in your head. It's the same for the kinds of expressions we're about to do. Like this. Okay. So this first one, 2x minus 7 over x minus 2 plus x plus 1 over x minus 2. So, do they have the same denominator? So what do we do with them? We add them together. And, again, we only add the numerators. Seriously, who is talking still? Shh. What? Did I tell you how one time... Okay, never mind. So, here we go. Never mind. Okay, after notes. So, combining like terms. 2x's plus 1x is how many x's? 3x. 3x. Okay. -7 plus 1 is? -6. All over x minus 2. Okay, now, can we simplify anything? Can we factor either the numerator or the denominator? Okay, how do we factor 3x minus 6? Akashni. Good. Everybody give it up for Akashni. Okay, then what? Anything? Or are we done? Ashley? Good, we can cross them out, so we're left with, good, 3. Everybody give it up for Ashley. Okay. All right. So they're easy when we have the same denominator, but I think you all know that we're not always going to have the same denominator. Okay, here we go. 6 over 5x cubed y minus 3 over 10x squared y to the 5th. Lydia.
I don't know exactly, but I remember something about like multiplying by the reciprocal or something like that. Is that this or
The reciprocal, that's later on. That's when we're solving equations. We don't do that when we're just simplifying
oh,
things.
that's least common
The LC, least common denominator. So let's do it this way. Basically, the way that it has to work is we have to have one of everything represented in each denominator, okay? So in other words, if we're looking at the 5 and the 10, those are easy. The least common denominator between 5 and 10 is 10, okay. Now, let's look at the x's. We have 3 x's in this one, and we only have 2 in that one. So the least amount that is common to both of them, wait, say that the other way around. I don't know how to say it. I'm not going to lie. X to the third. Good. Okay. Perfect. Now, how about the y's? Y to the what? Fifth. There are 5 of them. Okay, good. Can somebody explain, better than I could, clearly, why 10x cubed y to the 5th is the least common denominator of those two? Marcy.
because you can multiply something, or you can multiply something from the, you can multiply those by something in order to get that, and both of them will end up matching that.
Oh, good. I like that explanation. Okay, everybody give it up for Marcy. That was a good explanation. So let me, in case the microphone didn't pick it up, she said we can multiply each of these denominators by something to get the least common denominator. Very good. Well said. Okay, now, so 5x cubed y. What do we have to multiply 5x cubed y by to get 10x cubed y to the 5th? Rachel.
2y to the 4th.
Good. 2y to the 4th. 2y to the 4th. Okay, how about the second one? We have 10x squared y to the 5th. So what's the only thing we need to multiply that one by to get 10x cubed y to the 5th? X. Good. All right, so we end up getting 12y to the 4th over 10x cubed y to the 5th minus 3x over 10x cubed y to the 5th. That is the worst 5 ever. Okay. Ever. I'm getting sick.
Me too.
Not the same kind of sick that my lovely sub told you all about, but a different kind of sick. So not okay. Okay, now what do we do? Now that we have the like denominators, are we all working on homework already? Hey, it's fine with me if you guys are doing that. It's when I ask a question and nobody answers that worries me, because at this point I'm like, oh my word, how far back should we be going here? Lydia. The question was, what do we do next? Subtract it. Okay. 12y to the 4th minus 3x over 10x cubed y to the... Are we in one of those places today where you guys want me to just kind of go through it and not interact with you as much? We can do that. That's fine. Okay, so from here, we want to factor anything or simplify anything that we can. Can we factor anything anywhere?
Yes.
What can we factor?
A 3.
A 3. And we're left with 4y to the 4th minus 1x, or x, all over 10x cubed y to the 5th. Anything that can be reduced from there? No. So we are done. All right, how are we doing on questions? You guys tired?
Yes.
Yeah. Rachel.
If like the first problem was subtraction, would we still combine the like terms?
Yeah, you always want to combine like terms. We're actually going to go through one where there's more after the subtraction sign. You just want to make sure you distribute that subtraction to every term on the top. Okay, other questions? We have 3 more. Okay. 3x over x plus 5 minus 9 over x plus 1. So, one denominator is x plus 5. The other one is x plus 1. So, what do we decide? You want me to just walk you through this?
Yes.
Oh, okay. All right. So, again, you have to look at these as units. Because this unit is x plus 5 and this unit is x plus 1, we need the common denominator here is x plus 5 and x plus 1 both multiplied by each other. So this is getting multiplied by x plus 1 over x plus 1. This one by x plus 5 over x plus 5. So now we're going to distribute this one, and we're going to distribute that one as well. So we get 3x squared plus x over x plus 5 times x plus 1. One thing I do want to say here is you don't want to actually FOIL or box out the denominators. In the end, the goal is to simplify, and simplifying usually means factor in some way, which you're going to get it back to this form anyway, so you'd be making more work for yourself than you have to. Yes? Okay. 9x plus 45 over x plus 5. Okay, now, this is where, if you have the subtraction sign and multiple terms on the right-hand side, you want to make sure that when you combine them, you distribute that negative to everything behind it, okay? So, we don't have any x squareds to combine with the 3x squared, so we're going to leave that alone. But we do have 3x minus 9x is negative 6x. And we don't have anything to combine this 45 with, no other like terms. But there's a negative times a positive 45 is minus 45. All over x plus 5 times x plus 1. Okay, factoring. Take out a 3, good. X squared minus 2x minus 15. So everybody think in your head, this is a diamond on the top. Two numbers that multiply to negative 15 and add up to negative 2. 5 and 3, which one has to be positive and which one has to be negative?
Negative 5.
Good. X plus 1, okay. Now, there will be situations like this where nothing cancels. That's okay. Just leave it like that. Jared.
Can't you, like, take a negative out of... No, wait.
No, it's a good. I like that you're thinking about that because I'm guessing you're looking at this, the x minus 5. Right. If you take the negative out of one of them, you're going to switch the sign of both terms, which still isn't going to match. It's only when the signs are exactly opposite of each term.
Oh, right. Yeah, that's not good.
Okay. Other questions? Marcy? Oh, we are.
How did you get from the 9x plus 45 to the 3x squared?
By, you want to go through and combine the tops together, so combine like terms.
Okay.
Other questions?
Okay. I see.
I really want Freebird's burrito. It sounds so good. Go ahead. Shh, I'm having a super deja vu right now. Yeah, go ahead.
It says find the lowest common multiple of each pair of expressions.
Yeah.
But it gives me like one equation, semicolon, another like equation. So am I trying to find the lowest common multiples of both equations, or am I trying to...
I'll have to look at it. Yeah, let me come look at it. Other questions that are on notes? Okay. All right. Next. 4x minus 5 over x squared minus 7x plus 12 minus y plus 7 over x squared plus 2x minus 15. Okay, shh. We have two more examples. And in fact, if you don't want to go through the last one, since it ends up being a little bit redundant, we don't have to. But you do have to be quiet while we go through this one. Okay. 4x minus 5 over x squared minus 7x plus 12 minus y plus 7 over, you guys can read it. Okay. Anyone have any ideas about how we can start this problem? For our viewers at home, a lot of us in the audience are very tired right now and they don't want to be engaged. They don't want me to engage with them. So, Michael.
Can we factor it first?
Good, I like that suggestion. So if we factor, let's do both of them. So we have 12, negative 7. The two numbers that work for 12 and negative 7 are what and what? Negative 3, negative 4, x, x. This one, negative 15 and positive 2. The two numbers that work there are what? Negative 3 and 5, x, x. Okay, so let's rewrite it with our factored versions instead. Now, here, if some of us are sitting there going, what is the point of, oh, let me take that. I know we're all sitting there doing that right now. But if you're wondering why we factor first, it's because can see is that now they both already have an x minus 3 in common. So you don't have to worry about multiplying that to the other fractions. Shh. Okay, if you're working on homework, fine, but shh. Okay, so again, each denominator has to have one of everything represented. So in this denominator, we have x plus 3 and x minus 4. This one, we have x minus 3 and x plus 5. So the whole denominator overall, to combine them, has to be x minus 3, x minus 4, and x plus 5, all three of them. So this one already has the x minus 3 and the x minus 4. It's missing the what?
X plus 5.
X plus 5, good. So we're going to multiply that. Let's move that minus sign over. I can feel my throat getting more and more sore as the day goes on. Okay, this one has an x minus 3 and the x plus 5. It's missing a what? X minus 4. This is where it gets really fun.
Oh, it's gonna get fun.
So scratch that. I know it's already exhilarating. Gets even more fun now. On the top, we've got 4x minus 5 times x plus 5. That is multiplying a binomial by a binomial. How do we do that?
You do that
Foil or the box. Good. See? More fun. I'm really tired.
Me too.
All right, here we go. You guys just want me to go for it?
Yeah.
All right, so, all right, we got 4x squared, negative 5x plus 20x is positive 15x, and then negative 25, x minus 3, x minus 4, x plus 5. Next one, we have, that should be an x. Sorry, you guys. It should be an x, not a y. I don't know why that ended up morphing to a y. Okay. So then the next one should be x squared plus 3x minus 28 all over x minus 3, x minus 4, and x plus 5. And then from here we want to make sure that we distribute that negative sign to everything behind it on the top so that when we go through and combine the like terms, we are subtracting them or doing the opposite sign. Okay, so here we go. We have 4x squared minus 1x squared is how many x squareds? 3x squared. Okay. 15x minus 3x is how much? 12x. And then negative 25 minus negative 28. Okay, so negative 25 minus negative 28. Double negatives turn into a what? A positive. So negative 25 plus 28 is how much? 3. And it's all over x minus 3, x minus 4, x plus 5. All right, how are we doing on questions? Now, is there anything that can be factored? On the top. A 3? 3 times x squared plus 4x plus 1. If we envision doing a diamond in our heads for that top part in the parentheses, are there ever going to be two numbers that multiply to 1 and add up to 4? No. So that is it. We are done. All right. How we doing now? Questions? Okay, let me show you the last problem and you guys can make a decision about whether you want to go through it or not, okay?
We don't.
You haven't even seen it yet, Underhill.
No.
Take a look. Turn it around. Eyeballs. Miss Kanowski says it a lot, right? Eyeballs in the front.
Yeah.
Did she say that?
What?
I love Mrs.
It's
Kanowski.
not a mullet.
Okay. A mullet? You're growing a mullet?
No, I wouldn't want a mullet. I don't think I could rock a mullet.
No.
I think Chaz could.
Okay, so do you guys want to go through this one? The
No.
only difference is that now we have 3, so you just have to make sure the common denominator works for all 3.
I think
No?
we've all given up for the day.
You're all giving up. No, that's not good.
Hey, Mr. Wong told me there's no shame in it sometimes.
I'll agree with that. I completely agree. All right, you guys have a homework assignment written up here. Everybody go ahead and get out a book.